Hello friends, I am Hemant Kumar Naik and today I will be discussing about my seminar presentation CHN 700. So I am sharing my screen. This is my screen. Yeah, right. So now I am in PowerPoint presentation slides. So I am going full mode. Right, so I am in first slide, Indian Institute of Technology, CHN 700 seminar. My topic is bimetallic catalyst for butane dehydrogenation. Right, it is Department of Chemical Engineering. So first I will discuss some motivation, then problem statement, then preparation method, results and the conclusion. So here you can see why we are using bimetallic catalyst because it provides enhanced activity, selectivity, stability, yes, and also development in characterization techniques like electron microscopy characterize the biometric character of particles much more accurately. Example characterize the structure and composition of individual particles. Right? So now, and also uh, the catalyst preparation which they have used like electrolysis deposition is advanced catalyst preparation method. So these are the motivations to do this work. And next is wide dehydrogenation, right? So here they have dehydrogenation of butane. Right? So because light olefins, like butenes, are feedstocks for valuable chemicals, we can produce varieties of chemicals from butene. That's why we convert butane to butene, and the demands of butene is also high. In naphtha cracking process, we use butene, and you can see with byproduct is hydrogen, so we can produce hydrogen as well, right? So that's the thing, guys, right? So now problem statement. What are the problem? So that we can work on this topic. Only some studies of palladium as a dehydration catalyst. So and uh, dehydrogenation of butane or palladium plastic limited, the gallium modified palladium catalyst exhibited high butane selectivity greater than 95% than monometallic palladium. So palladium-based bimetallic is particular interest of dehydrogenation, lower cost of metal precursor. So metal precursor like for palladium, PDCl2 is the metal precursor. So its cost is relatively low. Right? So electrolysis deposition, bimetallic catalyst preparation is relatively easier and cheaper. Right? So bimetallic catalyst is also we can produce CG. Right? So this is the preparation method, deposition. So first preparation of support. So for support, aluminum nitrate solution is there, and after this at room temperature for 15 minutes, and release by ammonia solution pH 10.5 we have to maintain. Then stirring for 60 minutes at room temperature. Right? After the aging, we have to do at aging at 75 degrees Celsius for 6 hours, and then cooling, washing, and filtration. After filtration, the whatever filtrate filter cake we have to dry in 1 800 degrees for 12 hours, and then the calcination we have to do calcination to remove volatile and moisture. So it will 550 degrees for 6 hours. Then we can produce the aluminum oxide. So this is support. And after that, biometric preparation, once we produce supports, then we have to deposit the metals, right? So We have alumina, and in this we have to perform 4 cycles. Right? Let's deposition method set up we have prepared, and after that in burner funnel we have to put alumina, and then you have to pass into an hydrogen solution of 20 ml. Right? So and after that for 10-minute holding time alumina into in that after that 20 ml of palladium precursor and then then passed, right? So and after that palladium is also deposited on the alumina. So this is the this complete the second cycle, right? So and whatever filtrate solution we are getting, we have to collect in different, and then again we have to pass into into ammonia hydrogen solution 20 ml, and then after uh, and again the next is next that's so platinum precursor solution 20 ml we have to pass, then platinum and the palladium both deposited on the uh, support. In this way we can produce bimetallic catalyst, right? So there are 4 cycles. So first cycle phase and second cycle filtrate, and then third cycle phase and fourth cycle filtrate. So in this way we can produce bimetallic catalyst. So some results, right? Whatever metal deposited, we can perform in energy dispersive stress. Then from that we got elemental analysis like pellet palladium alumina one sample is there. So in this palladium load is 1.1 weight%. So total weighting will be 1.8. Right? So for bimetallic platinum loading is comes out to 1.4 and palladium is 0.6. So uh, from HDX analysis we can get and physical properties of catalyst. For that BT surface area when measured. Right. So palladium platinum has BT surface area which comes out to be 181 meter square per gram. For volume is around 0.327. Average for diameter comes out to 6 millimeter. So this way, and for average particle size and corresponding standard deviation, monometallic and bimetallic catalyst. So this is from TEM analysis we can get, right? So this is the TEM picture. You can see morphology of the catalyst. So and this is the uh, size count, right? So frequency versus cluster size. So mean cluster size was 10.4 nanometer. Right? So in the comparative study, volume at job versus readability curve. This is a for size distribution, and this is a XRD image. This is FTIR. To know acidity of the sample, we can perform FTIR, and for CO adsorption, adsorption versus wave number, dehydrogenation of reaction. So C4H10 is producing butane and also hydrogen. So this is the conclusions. Like the Limna supported palladium platinum based bimetallic catalyst were prepared by modified electrolysis deposition method and evaluated for performance of butane dehydrogenation reaction. The bimetallic palladium platinum catalyst exhibited superior performance in terms of conversion, selectivity, yield, and stability compared to that of monometal like palladium or platinum based monometallic catalyst. The superior performance may be attributed to strong synergistic interaction between metals, stronger metal support interaction, and a lower acidity of catalyst. The higher activity and palladium platinum metal resulted in higher conversion for bimetallic catalyst. The lower acidity resulted in higher butane selectivity and stability for bimetallic catalyst by minimizing the taking and the second reactions. Some more conclusions in this way. So the metal deposition order of bimetallic catalyst also affected their performance. Co-deposited and sequential deposited. Yeah. While co-deposit palladium exhibited higher activity and sensitivity in comparison co-impregnated bimetallic is due to higher metal dispersion and suppressed co-formation for farmer. These are the references. And thank you guys. So this how I start here.